In this video, we'll discuss how to select the optimum perforating system for a particular well, as well as some of the most common mistakes and misconceptions that lead to suboptimal system selection. Picking a perforating system does seem straightforward, and indeed a lot of people are going straight to the vendor's catalogs and picking what seems to be the most appropriate system for their well. The challenge is that the data in those catalogs is usually generated in tests that are carried out at surface, in concrete targets, and unstressed conditions, and that doesn't give us a good indication of what those systems are actually going to do downhole. So while those tests still have their place, they're not necessarily useful either. It's a little bit like the MPG claims that car manufacturers will make in their TV adverts. You can't necessarily make an informed decision as to which vehicle is going to give you the best fuel economy with your particular set of driving conditions. Well, there's still a lot of useful information in a vendor catalog, such as the system dimensions, mechanical performance, and pressure ratings, in particular how the diameter of a gun system is going to change after detonation. That can be very important for being able to retrieve the gun from the wellbore after it's been fired. The important thing to recognize is that while there might be an okay correlation between the penetration and entry hole values in the catalog and, for example, what you'll get in moderate strength sandstone, once we get away from that into shale, hard carbonates, very tight sandstones, it gets extremely difficult to predict what might happen. In general, the most commonly used correlations will over-predict penetration into harder rocks, but it's not as straightforward as that, or we'd simply adjust the correlations. In certain circumstances, we might see System A outperforming System B based on the vendor catalog data, but when we test in harder rocks, we see System B outperforming System A. So if you'd chosen System A based on the vendor catalog data, you'd have made the wrong call. Our clients are shooting everything from chalk to shale to coal and 50 rock types in between. Fortunately, there are a range of options for generating more reliable data on which to base an informed system selection. Obviously, you could generate a short list of systems and try each of them in a few wells to get a comparison of well performance. But I don't know many operators that are willing to sacrifice a dozen or more wells in the name of perforating system selection. That would be the ultimate field trial. And well-to-well comparisons are notoriously difficult. Reservoir properties can vary a lot, even between closely spaced offset wells, and it becomes very difficult to get a true apples-to-apples comparison. When we want to generate more reliable data, we actually turn back to the same API document that describes the concrete tests from which the vendor catalog data are drawn. It actually has 5 sections describing different tests, of which the system test in concrete is just the first. Section 2 describes a test where we shoot a single shape charge through a steel and cement target representing the gun, the wellbore casing, and the cement into a rock target subjected to conditions more typical of what we'll find downhole. When we cut open those rock targets, we can see an actual perforation tunnel and measure its geometry. Comparing Section 2 tests for different shape charges using the same rock target gives us a much better way to predict which system is going to perform better in the well. Though that might sound expensive, when you factor in the millions of dollars of well value that's on the line throughout the well's life cycle, a few $1,000s spent on Section 2 tests could be money well spent. The more sophisticated operators certainly are taking advantage of these tests, especially for their higher profile projects. And once they've run a test for a field or an asset, they often come back for more because it clearly demonstrates that that result could not have been predicted from vendor catalog data. Geodynamics believes strongly in Section 2 testing, and in fact, we've been building our product line around it for almost a decade. Now we're seeing the rest of the industry and the API committee moving to establish Section 2 as the new performance benchmark. We think that's a great step forward for the industry. So Section 2 tests are clearly a major improvement over the concrete tests at surface. But let's remember the ultimate objective when we're perforating is to create an effective flow path between the wellbore and the undamaged reservoir. So we need to be talking about tunnel geometry and quality. In other words, the combination of diameter, penetration, tunnel wall characteristics, tip geometry, and tunnel cleanout that yields the most effective flow path. That's a much more complex analysis, and so it requires a more sophisticated test. Section 4 of the recommended practice is designed to evaluate a perforating system under representative conditions, that is, simulate the downhole environment as accurately as we can within the limitations of our labs. We first characterize a rock core by measuring its density, porosity, and compressive strength, then flow through it to determine its permeability. The core is wrapped in a rubber sleeve and placed inside a pressure vessel where internal and external pressures are applied to simulate the overburden and the pore pressure. In an adjoining pressure vessel separated by steel and cement plates to represent the wellbore configuration, the shape charge is housed in a properly scaled gun section and placed under wellbore pressure conditions. After the charge has been detonated, flow is once again initiated through the core to measure post-shot permeability. In other words, to measure the effectiveness of that tunnel as a flow path. The whole process of core preparation, test setup, execution, and analysis can take several days, so it can be significantly more expensive than a Section 2 test. But the value of the information generated is also significantly greater and really forms the basis of making an informed system selection decision. It's also the approach we take when customizing or developing a solution for a particular situation. And we're going to be talking about that later in the series. As with all completion engineering decisions, it's about applying an appropriate level of engineering rigor for the situation. If you're shooting something straightforward, you might be able to get away with making a decision based on vendor catalog data. Personally, I'd never rely entirely on that approach. Whether you're working with Geodynamics or one of our competitors, we believe that this kind of lab testing is an essential step in making the right decision. The first step is to gather a comprehensive set of data about your well and the target formation, and to share those with your preferred perforating vendor. That will narrow down the list of candidate systems. Across the industry, we've already carried out thousands of tests with different systems in different rocks. So the next step is to ask your preferred vendor if they already have data for the systems you're evaluating under your well conditions. It's perfectly possible that new tests won't need to be carried out, and that would save you time and money. If your vendor doesn't have relevant data, then obviously the next step is to set up an appropriate program of lab tests. In the end, the perforating system selection decision you make based on these lab results, rather than just vendor catalog data, is much more likely to yield a productive, profitable well. On behalf of Hart Energy and Geodynamics, thank you for joining us today in the second of our 6-part series on perforation. We look forward to seeing you next time.